Hello, can you all hear me now? Yeah, sorry. So the thing was muted. Can you hear me now? Thanks. Think. Can you all hear me now? Okay, so I was talking about last time we had done NMTC. Yes, awesome, cool. So last time we had looked at NMTC, objectives like MCQs, and now we are looking at NMTC fill in the blanks, right? So I think I should always do a mic test first, right? So thank you uh, for telling me Nabanyu and Pastre. All right, so you can also tell me if you can see what I've written. Actually, I've written a bunch of things here, but I think it's not visible on the screen. Hope this is visible. Please let me know. All right, I think for some reason it's not visible on the screen. Okay, so let's look at. All right, so hopefully it will be visible from now on. So basically you have a x power 10 plus 1 polynomial divided by x square plus 1, and once you do that, you will get a quotient, you'll get a remainder, you get a quotient as x power ax power 8 plus, you get some quotient. Then what is the value of a power 2024 blah 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 all the way up to what are the coefficients power 2024. Oh, I thought it was remainder actually, so it's actually quotient. So well, essentially, they didn't say what's the remainder though, right? I mean, maybe it doesn't matter. So if you multiply x square plus 1, I mean, the remainder, obviously when divided by x square plus 1 can only be like some alpha x plus beta is equal to x power 10 plus 1. Okay. And I guess you can sort of divide and just get the quotient. Yeah. So for example, you can, the leading coefficient x square into ax power 8 is ax power 10. So if you're comparing both sides, you'll get a is equal to 1. And to get x power 9 coefficient, you can I think essentially divide it, or you can just multiply it and compare. So I'm actually multiplying out and comparing by division algorithm. You guys know what division algorithm is. If you have a polynomial, you divide it by some divisor d, you'll always get a quotient and a remainder. And the polynomial can be written as the divisor into quotient plus remainder. And the remainder always has degree less than the degree of the divisor. So therefore, the degree of the remainder should be less than 2. So it should be a linear polynomial of the form alpha x plus beta. So anyway, you can now compare coefficients on both sides. You can actually really try to divide x power 10 plus 1 by x square plus 1 by long division, or you can sort of multiply this out. I don't know if there is a sneakier and easier way to do it. But this is not too bad, I think. Like if you notice a leading coefficient, if you multiply, then a x power 8 into x square is a x power 10. Comparing on the other side, you see a is 1. And similarly, a x power 8, now you put a is equal to 1, right? You put a is equal to 1. Then you see the coefficient of x power 9 is x square into x power 7, which is b, and 1 into, so the next coefficient is, I think, x power 9, which can only be gotten through b x power 7 into x square, which is 0, right? So b is equal to 0. Okay, people are saying you cannot see anything that we are writing. Okay, I don't know what to do about this. So why can't you see what I'm writing? Can you see it now? Some bunch of x square plus 1 alpha x plus beta. Is it okay now? Okay, so this think, yeah, I can keep Teams open too on the side. So can keep Teams open, but you can, I'm looking at your chat here. I can see what you guys are typing in chat. So unlike last time. Okay, but the thing is somehow, okay, things that I'm writing you guys are not able to see. Now can you see? Still can't see the full screen. Okay. I think now it's better. You are able to see what I'm writing. I can see it in runtime. I scribbled something on the left. Yeah, but the full screen is not visible. You're right. I don't know why that is the case actually. There's some issue. All right. So I'll try to write on the left maybe as much as possible. Yeah, screen is zoomed in. I know. So I don't know why. I can zoom out like this. It's very awkward. So okay, now I think all of you guys can see the full screen. Yeah, I'm sorry for the aspect ratio. All right, so let's solve. So basically what I'm doing is I'm just comparing. We basically already solved ax power a into b. So we basically solved a into a is 1. We already got by comparison. B x power 7 into x square will give you a x power 9 term. So b is 0. Okay, so b is 0. This is what you'll get. So this is 0. And I guess the odd terms might, I mean, maybe it's a general theme. Let's see. So if you go look at c x power 6 now, c x power 6. What is the next term after x power 9? You'll get x power 8. Now x power 8 you can get in multiple ways, right? You can, x power 7 coefficient is 0. But x power 8 you can get by 1 into x power 8 into 1 and x square into x power 6. So you can get it in c plus 1 is 0. So you'll get c is equal to minus 1. So you get c is minus 1. And so basically it looks like you're getting just 1 minus 1. Okay. Is that what it is? So you'll get d. So next is d, x power 5. Now x power 5 can multiply x square and give you an x power 7. Or you can get, okay, so we are already sort, how do we get, so I think we are done with x power 10, x power 9, x power 8. I think c came because of x power 8. Now next is x power 7. To get x power 7, you can multiply x power 5 with x square, which is d into 1, or 1 into x power 7, which is 0. So d also is 0. Okay. So I think that's what is happening essentially. Like if you look at the odd powers, it will become 0 because the only way you can get is the previous odd power whose coefficient is already 0, and the new odd power x square will multiply and it will give you 0. It looks like, and at least up to up to x cube. So I'm guessing the same logic works here, and you will sort of get x cube also, f of f also 0. And but okay, so that is x power 7. Next, x power 6. How can you get x power 6? You can get x power 4 into x square is e, and 1 into minus x power 6. So you will get e minus 1 equal to 0. So e is equal to 1. Okay. So you are essentially getting 1 minus 1, 1 0 minus 1 0 1 0, and essentially, yeah, it's alternating in 1 and minus 1. Up to a point it's fine, okay, but I think there is a bit of an issue towards the end. I'm not sure. So if you basically multiply, oh yeah, you'll never have an issue. I see. That's correct. Because the lowest thing that you can multiply here is x square into k. So you can go all the way up to k, I think. All right, so let's see what happens next. So I think we have calculated all the way. So how much have we calculated actually? X power 10, x power 9, x power 8, x power 7, x power 6. It's the 6 that we were stuck at just now. Yeah, x power 5. Again, x power 5 is the same logic. x2 into x cube will give you 0. X power 4. X power 4 is the new thing. So you'll get g plus 1. So you'll get minus 1. Again, we'll keep alternating. And finally, what do you get? So x power 3. You will get, anyway, is it the same thing? X power 3, how can you get? X square into hx and x cube, yeah, same thing. So that's 0 again. H is 0. So finally, you have x square, and x square coefficient if you want to get. Okay, I think it went into my screen share. Okay, all right, my portrait. Okay, so it's a big problem. Okay, all right. So now I should be mindful of the video there. All right, so x square, k into x square plus 1 into gx square. So k is again 1. So k is 1, as you guys said. So as people said in chat, they've seen it, it's always alternating 1 0 minus 1 whatever. So therefore, this is just all power 2024 are all 1. So it's 1 plus 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. The answer is 9. Okay, the question now is fine. I mean, we can do it this way. We can also do long division. But was there a shorter way to do this? Was there a shorter way to factorize x power 10 plus 1 using some identities or something? Did anyone do it by identities is the question. Is there a way to do it by identities? So actually, now that I think about it, x power 10 plus 1 is essentially x square power 5 plus 1, right? It's x square power 5 plus 1. And I should have realized it's so easy. A power 5 plus 1 is a plus 1, it's so short, okay. A power 4, you guys know the drill, right? I mean, I'm sure all of you know, a power 5 plus b power 5 is a plus b into a power 4 minus a cube plus a square plus 1. So short, right? And x power 8. So you didn't have to do that at all, whatever I did just now. It's a very short solution. See, that's it. So you can read off the alternating plus minus sign, and it's really short, right? Cute. So basically, all the only thing you guys needed to know was, you know, a power n plus. So what's the takeaway? IOQM is coming close, so you know it's great to have things known. So a power n plus b power n is odd. The answer is a plus b into a power n minus 1 minus a power n minus 2b plus a power n minus 3b square minus dot dot dot. Okay, minus 1 power b n minus 1. I guess I think plus minus depends on what is the last thing that I think I don't know whether what will happen in the end. Basically, it depends on minus 1 power n minus 1 essentially. Correct thing to write there would be minus 1 minus b power n minus 1. Okay, so this is the identity. This identity really comes from a power n minus b power n, where we replace b by minus b. Sorry, so I think apparently the answer is not 9. Did I make a calculation mistake? So as we just now factorized x power 10 plus 1, I think in chat somebody is noting the answer is 5. That's correct. I think the answer is maybe 5. I might have made a mistake. Just one. X power square 4 x power 8 minus x power 6 plus x power 4 minus x square plus 1. And if that is the case, there are 5 coefficients which are non-zero. That's correct. So 5 of them, yeah, not all are 1. Alternately it's 0. You are right. That's why it's 5. There are 5 non-zero coefficients which are all plus or minus 1. So when you exit the part 2024, they are all 1. 5 coefficients. So that's why it's 5. You're right. Yeah. Thank you. Correct. You're right. Yeah, you can also say it in chat. Yeah. All right. So next question. So hopefully this identity, if you use it, was way faster. You don't have to really do long division. Next question. The equation x power 4 minus 4x cube plus ax square plus bx plus 1 equal to 0 has 4 positive roots. Then a plus b is. X power 4 minus 4x cube plus ax square plus bx plus 1 has 4 positive roots. Okay. What does that mean? If all the 4 roots are positive, how does one figure out when we have 4 positive roots? So, okay, so in chat somebody is suggesting that you can look at a special case where you know 4 positive roots exist, where all are equal roots, that is x minus 1 the whole power 4 is equal to 0. If you do by binomial theorem, you'll see x power 4 minus 4x cube plus 6x square minus 4x plus 1 equal to 0. You know this one has 4 positive roots, all are equal to 1, and you can just compare. A is equal to 6, b is equal to minus 4, so a plus b is equal to 2. They never said that the 4 positive roots are distinct. So you can always use binomial theorem. That's a great suggestion actually. It's very nice. Yes. But it's interesting though, right? Like although you can kill this problem, like solve it and go ahead, it's an interesting question to wonder whether This is the only solution, right? I mean, sure, I mean, if they have asked in the question, this is an answer, this better be the only answer, right? So you answer this definitely, but after you come back, I mean, we have time here in the stream, so we can wonder, is it that this A, B, this is the only solution? It's interesting if it is, right? Has 4 positive roots, because why can't there be, for some other value of A and B, why can't there be some other polynomial? I mean, why can't there be other than 1? I mean, it could be yeah, as Navanu says in chat, yeah, we used x minus 1 power 4, not x plus 1 power 4, x minus 1 power 4, because there's a minus sign here. Certainly that'll give you the answer, but I'm a little not so sure. Is there a way we can answer this question? So I'm keeping my teams open as well. Yeah, the other thing is to do Vieta's relations, that's correct. So if alpha, beta, gamma, delta are the 4 roots, you could try to do some Vieta relation. But actually there is theory, I think, which tells you some conditions under which pairwise relation is A, triple relation is minus B, and alpha, beta, gamma, delta is 1. So if all of alpha, beta, gamma, delta is positive, oh, so nice, AMGM inequality, right? Is that correct? AMGM inequality, notice alpha, beta, gamma, delta are positive, and their sum is 4 and the product is 1. What do we know about sum and product? AMGM, right? Alpha, beta plus gamma plus delta by 4 is greater than or equal to 4th root of alpha, beta, gamma, delta, and equality if and only if alpha equal to beta equal to gamma equal to delta. If alpha, beta, gamma, delta are positive, I mean non-negative, only AMGM works only when they are non-negative. So since they have told us it's positive, we can apply AMGM inequality to this sum, and that will tell us if you put 4 here, then it will become 1. This side also will become 1. So it's equality case, and equality happens if and only if alpha equal to beta equal to gamma equal to delta. Awesome, right? AMGM. I hope that's nice, right? Everyone followed it. Hope everyone knows the AMGM equality cases if and only if all the alpha equal to beta equal to gamma equal to delta. It's very nice, yes. So indeed, alpha equal to beta equal to gamma equal to delta should happen. That's for sure, and all of them should equal 1 because the sum is 4. So it must be x minus 1 power 4. You can conclude. See, it's such a nice prove that question, right? It's such a sad thing about fill in the blanks and integer type MCQs, because some student who noted, they should get more marks. I mean, come on, now people can just guess. It's not nice, I feel. Okay, anyway, let's move on. So I had fun solving that. Okay, in the adjoining figure, BOC is the diameter of the semicircle. Did you guys do this? DE is the tangent at D. AB is K times AE. Then the numerical value of K is, okay. So if you take this circle and if you draw, what do you get? So let's see. You can draw here. Is this my mark? Okay. So one thing is it is 90. What do we know, by the way? I think I'm not following the problem. This is a diameter BC with center O. DE is tangent at D. Okay. And wait, AB is, I mean, okay, we have to maybe figure out from the picture. This 90 they have given, I think. Okay, which means AB is also tangent. Wait, so ED equal to AB, right? ED equal to EB, sorry, because tangents are equal in length. They want to know AB square, I think some power of a point, most likely, I don't know. Okay, so let's see, AB square is AD into AC, that much we know. I think, okay, more than power of point, we also know like similarity. But let's see, AB is K times AE. How do you do this? KEE square is AD into AC. But what do we know about AE? AE is AB minus EB, I guess. AB minus EB and EB is ED. So connect BD and OD apparently. Alright, so let's connect BD and OD. This is 90. These are equal. That much we know. Next, we know this is a kite. I know that that's useful. AB is K times A. Is there some similar triangle here, or this is right? Oh, are these three also equal? No. Oh, this is 90. This is 90. Oh, I see. I see. Just a minute. I'm not looking at chat, but this is 90. So this is this and this are also equal. Because in a 90 degree, these three are equal. Then AB. Oh, we are done, right? AB is 2 times AE. Is it 2? Answer is 2. Yeah. Oh, good evening. More people joining us. Okay, so let me just quickly repeat the argument, right? I think I was given the suggestion to join. Right. So my proof is just this, okay? This is a configuration you have to memorize, all of you, whatever you're doing, like in geometry, most basic configuration, Thales theorem. The configuration is this, that if you have a right angle triangle, then these three, and if you take the vertex and join it to the opposite midpoint, right, then these three lengths are equal. Conversely, if you have a triangle, if you have like 3 segments which are equal like this, anywhere in life, if you have 3 equal segments like this, then this is 90 degree. That's Thales theorem. Obviously, because you can draw a semicircle with this fellow as the center. Okay, so that is the main configuration to spot. That's all this problem repeatedly checks. So there's a nice suggestion which suggests join this and join this, and then you instantly see without almost any calculation that this is 90, we know. Sorry, this is 90 because angles in a they have given it's a semicircle. So you don't even need that these three are equal. You just need angle in a semicircle is 90. So the other piece is also 90. But since it is 90 and we already have these two lengths equal, I think it will force this also to be equal. Okay. So we are done. Okay. Oh, the configuration I'm drawing is I think below. Let me, sorry, yeah, thanks. Thanks, Rishan. I think I have to zoom out. Great. Okay. Thank you. Looking at the chat, yeah. Okay, so let's move on to the next question. Oops. In triangle ABC, tan A is to tan B is to tan C is 1:2:3. And if AC by AB is P root Q by R, blah, 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 whatever. We should just figure out what AC by. Tan A is to tan B is to tan C is 1:2:3. What do you do from tan A is to tan B is to tan C? Now from tan A is to tan B is to tan C, you can certainly, I think, try to get sin A is to sin B is to sin C or something, then we are done, right? AC by AB is sin B by sin C. So we really need to get the ratio of sin B is to sin C. So what do we know about tan A is to tan B is to tan C? Actually, we know a homogeneous relation tan A plus tan B plus tan C is tan A tan B tan C or something, but that's not useful, I think. I mean, obviously that matches. I mean, 1 plus 2 plus 3 is 1:2, 1:2:3. I think you should just figure out sin A is to sin B is to sin C from this, which you should be able to figure out, I think, right? So how will we figure out from tan A, tan B, tan C, sin A, sin B? How would we do that? Did anyone do this? No? So let's see. So sin tan A, well, actually 2 tan A by 1 minus tan square A, 1 plus tan square A is like, oh, but it's sin 2A. I see. Well, this is a roundabout method. I guess should be an easier way. I mean, okay, here's a roundabout way of, okay. You can try to get tan a by 2, and from there you can get, see, 2 tan a by 2 by 1 minus tan square a by 2 is uh, tan a, and 2 tan a by 2 by 1 plus tan square a by 2 is sin a. Okay, so these two facts, some well-known thing, right? Hopefully you guys know. If you don't know, you can quickly prove, right? I mean, this is standard double angle identity, right? I mean half angle identity. Sorry, this is the half angle identity. 2 tan a by 2 by 1. This comes from this tan a plus tan b by 1 minus tan a tan b. You can put a equal to b equal to a by 2. You'll get this. This you can get directly with basic 1 plus tan square a secant square a, and secant square a goes up, becomes cos square a by 2, and cos square a by 2 cuts a cos a by 2 at the bottom, and 2 sin a by 2 cos a by 2, and you get sin, whatever. Okay, you guys can get it. So some standard boring trigonometry. So, but the point here is that maybe we can use tan a is to tan b is to tan c, or we can use that other, some other identity which was faster rather than doing this algebra. Trying to see if I can avoid doing algebra. Is there some other way to do this? No, but if you take tan a, tan b, tan c as k2k, 3k, you can, will you get, oh, it's not homogeneous. Okay, I thought it's homogeneous and I avoided it. Tan a plus tan b plus tan c. Yeah, that's correct. It's not homogeneous, right? Tan a, tan b, you're right. This is not homogeneous. You're right, absolutely. So k plus 2k plus 3k, but k 1 plus 2 plus 3 is 1 into 23. So I thought k was 1. So 3k. I automatically thought k is 1. So you basically got, yeah, you're right though. So 3, 2, 1 plus 2 plus 3, 6 will cut 3 into 2. You'll get k cube is equal to k, and you'll get k cube is equal to k. So which implies k is plus or minus 1 or 0. So if you want to take them to be 1, then you get tan a is 1, tan, okay, all right, that's correct. So I missed I said first and I jumped through that. I noted tan a plus tan b plus tan c is tan a, tan b, tan c, but I thought it's homogeneous for some reason. Okay, it's not, you're right. Okay, so that was the point. So tan a is 1, tan b is 2, and tan c is 3. Now you explicitly know, right? Now you can calculate, right? So if tan a is 1, you can calculate what sin a is, right? I mean, if tan a is 1, okay, tan is 45. So sin a, as we know, is 1 by root 2. But that's not useful. I think we need AC by AB, which is sin B by sin C. This is what we want. So you can calculate that from these two. Tan B is 2, then 2 by 1, so root 5. So sin B is root 2 by root 5. And sin C is 3, 1 root 10, so 3 by root 10. So the answer was 2 by root 5 by 3 by root 10 and some root 2 by 3 root 10 by root 5 is root 2. So 2 root 2 by 3. So answer was 2 plus 2, 4 plus 3, 7. Right? Yeah, done. Okay, thanks. So basically I should have used tan A plus tan B plus tan C. It's not homogeneous. Hopefully all of you know tan A plus tan B plus tan C is tan A, tan B, tan C. It's a well-known identity. It comes from, well, you can prove it directly by rearranging, like, using 180 minus C is A plus B essentially, and taking tan on both sides. That's the hint if you want practice. Just practice this. A plus B is 180 minus C, take tan on both sides, rearrange to this identity. Right? Yeah. Cool. Yeah, I can go through the argument again. I'm getting messages. Can I go through the argument again? So I can. So let me just quickly go through if it was too fast. So see, the idea was, first you should know this identity, okay? Tan A plus tan B plus tan C. So in trigonometry, right, there are hundreds of identities. In principle, really you can't really learn everything, but I mean, you may not be able to learn everything in a course, so you should sort of practice some things on your own. So this is one of the, but this identity should be known. Tan A plus tan B plus tan C is tan A tan B tan C. Supposing you knew this identity, they have said tan A is to tan B is to tan C is 1 is to 2 is to 3. So let the proportionality constant be k. That means tan A is 1 into k, tan B is 2 into k, tan C is 3 into k, and this is k into 2k into 3k. Now if you calculate this, you'll get k plus 2k plus 3k is 6k, k into 2k into 3k is 6k cube. This implies k cube is equal to k. Okay, so this implies k is either 0, 1 or minus 1 if you solve. I mean, k cube equal to k, the only solutions are 0, 1, minus 1. And I then put k is equal to 1 here. Actually, it's not really clear, but because tan can be obtuse, so k can be negative. K can't be 0. If k is 0, then there is no tan A, tan B, tan C is 0, then it won't be angles of a triangle. You can have all tan negative, but then all of the three can't be. If k is minus 1, all three will be all three will be negative, and ABC will all be obtuse. This cannot happen in a triangle. So k is forced to be 1. Okay. So once k is 1, then you get tan A is equal to 1, tan B is equal to 2, and tan C equal to 3. Okay, these three things you get. Okay. Now you have to calculate AC by AB actually in the problem. By sine rule, you know AC is 2R sine B, and 2R sine B, and AB is 2R sine C. You know that. So this is what AC by AB is, which means this is just sine B by sine C. So now we are done, right? We know tan B. From that we can calculate sine B, right? You know, in a triangle, if you know tan B, imagine a right angle triangle where tan B is like 2 is to 1. Then you can calculate by Pythagoras theorem, the third side is root 5. So therefore sine B is 2 by root 5, adjacent by, opposite side by hypotenuse. Not adjacent, opposite side by hypotenuse is sine B, 2 by root 5. Similarly, you can calculate sine C is 3 by root 10. Okay, so that's what I did, and I just took the ratio. Hopefully that's fine. Okay. Okay, so 20. Simon was given a number and asked to divide it by 120. He divided the number 5, 6, 7, got 3, 2 reminders respectively. Then the remainder when divided by 120 was. Okay. This people would have done for sure. Was to ask to divide the number by 120. He divided by 5, 6 and 7 and got 3, 2, 2. This is standard Chinese remainder theorem, right? Hopefully everyone did it. Chinese remainder theorem. So basically there was a number which is 3 mod 5. Actually it's even easier than Chinese remainder theorem. I mean, yeah, sure, you can use Chinese remainder theorem. That is like some hammer. N is 2 mod 7 as well as 6, right? Which means n minus 2 is divisible both by n minus 2 is divisible both by 7 and 6, and 7 and 6 are relatively prime. So that means n minus 2 is divisible by 42. So directly you can write, you can combine this easily, like the Chinese remainder part becomes very easy. It just becomes a double. N is congruent to 3 mod 5 and n is congruent to 2 mod 42. Now you can do by trial and error actually at this point. Like you can be like, oh, 2, then 44, and just keep trying until you get it. Like, 2 is not true. 44, if you add 42 to it, it's not 3 mod 5, it's 4 mod 5. Then you can add another 42, right? And in fact, 42 itself is like 2 mod 5. So you have to keep adding until, you just get 3 mod 5. So next one, if you add, will become 6 mod 5, 6, which will be 1 mod 5, next one. So in other words, another 2 times 42, that's it. So 86, another 42 will finish the job. 2, 8, 4, 128. So I think 128 is 3 mod 5 and 128 is 2 mod 42. I guess. I mean 42, I'm guessing that 42 into 3 is 126. Yeah, that's correct. So certainly 128 is one such number, and when divided by 120 the remainder is 8. Yeah. So you can just do trial and error also. Like, I mean, if really they wanted you to use Chinese remainder theorem, I guess they would have given some harder looking numbers. Here you can just do trial and error and get it. Just play around with the numbers a bit, and basically the key thing that will allow to quickly solve the problem was the fact that 6 and 7 both were leaving a remainder of 2, which means 42 should have left a remainder of 2 when divided by n. That is like the key point, right? I think. Okay, cool. Right, so any questions? So I guess you can move on. The greatest number that leaves the same remainder when it's divided by 30, 53 and 99 is, next question. So the greatest number that leaves the same remainder when divided by 30, 53 and 99 is, okay, this is a different type of question. So what are we asking? You want a number n, and when you divide by 30, n minus r should, this is a number which when you subtract r from it, the greatest number that leaves the same remainder when it divides. Okay. All right. So basically it's saying 30 can be written as some a n plus r, q1 n plus r, 53 can be written as q2 n plus r, and 99 also can be written as q3 n plus r, right? That's what it's saying. It's the greatest number with that property. So n should divide, if you subtract, it means that number n, remainders will subtract. So n should divide the differences for sure, minimum. N should divide 23, n should divide 46, 99 minus 53, n should divide 99 minus 30, which is the sum anyway, it will divide then. So n should divide 23 and 46 for sure. But 23 is a prime, so n can only be 1 or 23. So 23 is an example, right? 23 could be the largest number. Let's see if 23 works. If it works, that's the answer. If not, n is equal to 1. So it's 23 leave. When you divide 30 by 23, you lose a remainder of 7. 53, 46 leaves a remainder of 7, and 99, how much is it? 23, what is 23 close to 99? 23 into 4, 92, yeah, 7, correct. 23 works, so 23 is the answer. So basically the idea was what? This is a nice, slightly different flavor, you know, like this. I have not seen this question before. So 30 is essentially n into q1 plus r. When n is that, let's say n is that greatest number, it leaves the same remainder for 30. When you divide 53 also, it leaves the same remainder. The quotient will be different, and 99 also is leaving the same remainder. So by division algorithm, you know that these equations can be written as 30 is n q1 plus r, 53 is n q2 plus r, 99 is n q3 plus r. Now we subtract 2 at a time. If you subtract 2 at a time, you'll see 23 is n into q1 minus q2, and similarly 46, if you subtract the second and the third equation also, you will see that 46 is n into q2 minus q3. So therefore n should divide 20. Basically in the first equation only you see that, right? I mean 23 is equal to n into q1 minus q2 is enough. This shows n divides 23, and since 23 is the only factors are 1 and 23. Okay, I'm repeating, but just to sort of, hopefully it's clear to everyone, right? Yeah, 46 is greater than 30, that's correct. So as a B notes in chat, can't have 46, that's correct. All right. You don't even have to check. So as Pasle is saying in chat, like You can check all numbers till 29. You don't even have to do because n divides 23, right? Only factors are 1 and 23. That saves you a lot of time. You don't have to check. Okay, 22. If, sorry, 22 I have not done. If f of x plus 1 is x square minus 3x plus 2, and if the roots of the equation f of x equals 0 are alpha and beta, then alpha square plus beta square is what? What if f of x plus 1 is? What? Why is this too easy? It's too easy, right? I mean, this is x minus 1 into x minus 2. And then you just replace x with x minus 1. I mean, f of x plus 1 is this, so obviously what is f of x? So you just, oops, what's happening? Okay, so you just, f of x plus 1 is this. So f of x is x plus, replace x with x minus 1 and you'll get x minus 2 into x minus 3. So its roots are 2 and 3. So answer is 4 plus 9, 13. Is that fine? Oops, I think the screen is not visible. I'm sorry, just a moment. Yeah, so 22 done. 23, the maximum volume of a cylinder is cut from a cube of edge alpha. The volume of the remaining solid is Ka cube, where K is blah blah, and taking pi to be 22 by 7, what is the value of P by Q? You have a cube of edge alpha. A maximum volume cylinder is cut. The volume of the remaining solid is Ka cube. I guess if you have like a cube, the maximum volume cylinder would be like what? Like you want a full cylinder, right? So it should be, I'm guessing that you could argue it must be, its radius must be alpha by 2, the circular part. Their height obviously is alpha again. So therefore the volume will be pi alpha square into alpha, right? So therefore if you subtract alpha cube, the total volume of the cube, minus pi alpha cube, is this visible? I think I'm writing somewhere below. What's this? Okay, so then it will be alpha cube into 1 minus pi. They have said pi is 22 by 7. So K is basically, sorry, I missed something. What is the volume of the remaining solid? Alpha by 2 cube, is it alpha by 2 cube? Alpha by 8, pi by 8. Right, I mean obviously alpha by 2 cube because the radius is alpha by 2, not alpha, diameter is alpha. So it's 22 by 7 into 8, which is 22 by 56. 1 minus 22 by 56. And whatever it is, I mean now we can simplify, get it 11 by 28, which is 17 by 28. So what is the answer? 17 plus 28. 38, 45 or something. Was that the answer? Oh, you guys got 17? Did I make a mistake? The volume of the remaining cube I think is 1 minus pi alpha, I mean alpha cube minus pi alpha cube by 8. That's correct, I think. Oh no, pi alpha cube by not 8. Pi, okay, correct, you're right. Okay, so let's do it more carefully. The radius is alpha by 2. So the circular area is pi alpha square by 4. But the height is still alpha, right? So it's just pi alpha cube by 4. So you're right. Maybe, I mean, I don't know whether you're right, but certainly what I said was wrong. So let's just see. Alpha cube minus pi alpha cube by 4, which is alpha cube into, or not alpha, oh, it's a, is it? It was looking like alpha to me. Okay. A cube into 1 minus pi by 4. Hopefully the screen is visible. Yeah, correct, Ishan, you're right. So 1 minus 22 by 28, which is into a cube. So it will be 1 minus 2 11s are 2 19s are. So 19 minus 11 is 8 by 19 into a cube. Now I think it's correct. Pi a square by 4 into a. Right, so 8 plus 19 is 27. Was this fine? I think this should be okay. Okay. So two people in chat are saying they are getting answer as 17 instead of 27. What mistake did I make then? Volume of a cylinder is cut from h. Maybe I'm making a mistake. A cube is the volume of the cube. Pi a square by 4 into a. So a cube into 1 minus pi by 4. Pi is 22 by 7. So 22 by 7 into 4 at the bottom. So 22 by 28 is 6 by 22 by 28. I think I made a mistake. 22 by 28 must be, should be 6 by 28. Yeah, I think it's some calculation mistake. 2 11s are 6 by 28. This 3 by 19. It's no, I'm still getting 22. What mistake am I making? Oh, 19 into 2 is 38. What am I saying? Okay. Sorry. 11 by 14. You're right. I mean 19 into 2 is, I make all these kind of arithmetic mistakes. So 3 by 14. Correct. You guys are right. Right. So the answer is 17. You're right. Not 27. Right. Absolutely right. Yes. Okay. Thanks. So what if irreducible quadratic factor phi x power 4 blah 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 is ax square plus bx plus c, then a square plus b square minus c square is? There's an irreducible quadratic factor of a degree 4 equation is ax square plus bx plus c. Then what is a square plus b square minus c square? I think when you see this minus one of them, it looks like you have to figure out ABC. So let's see, what is this quadrat? What is this quartic? Can you guess its root or something? One root, like 14. What is sum of coefficients? 14. Yeah, sum of coefficients is 0, right? So which means x is 1 is a root for sure, right? And there's an irreducible quadratic factor apparently, which means another root also must be guessable. Maybe it's a repeated root or something, x equal to 1. By the way, you guys know how to get repeated roots. If you know calculus, you can just differentiate, right? I don't know whether that's useful here. 20x cube, if you differentiate, 27x square minus 4x minus 4 is, yeah, this is not okay. It's not a repeated root because when you put add 1, it is not working. Okay. Alright, so x equal to 1 is certainly a root. But how do we get the other quadratic factor? So x minus 1 into x square plus bx plus c into x minus alpha. So one thing is we can try to get the quotient by long division. Maybe that's too long. Is there some smart sneaky way? Ax square okay. So I'll check teams. Yeah, okay, I'll check teams, but you know, so when I'm solving, I'm not able to look at the thing. I have to think. So if you look at 1 is a root, actually you can try to divide and get another root. So Yeah, I think yeah, as Abhi notes, the standard values to check is 1, 2, minus 2, minus 1, 0, exactly. So it turns out minus 2 is the root apparently. Okay, 5 into minus 2 power 4. That's a standard Olympiad practice, right? I mean, checking small values immediately. Okay, so it's like 16 fives are 80, minus 72. Yeah, but it's a bit of arithmetic is a bit tiring. So it's like, what do you get? 8. Yeah, it cancels. Yeah, it's not bad. So indeed, you should check. Okay, so basic tip, if you don't know, just make sure you check plus or minus 1, plus or minus 2, even up to plus or minus 3 or plus or minus 4 sometimes. Okay. So certainly, often if they are kind enough, it will be within plus or minus 2 or 3 maximum. So yeah, x plus 2 is a root. So you get x plus 1 into x plus 2 is a root, and then it's over, I think, right? Once you get those two, you are done. You can use whatever you want, like sum of root, product of root, something you can use and get the remaining. Like, let's say, 1 is a root, and minus 2 is one of the roots. Then the remaining two roots are alpha, beta. Then the sum of roots will give you minus 9 by 5. And the product of roots will give you alpha into beta into 1 into minus 2 will give you minus plus minus plus. So it will give you minus 8 by 5. And so indeed you can essentially basically just get alpha beta is minus 8 by 5. No, I have not written x minus, this is alpha. This alpha is minus 2. Alpha is minus 2. I mean, anyway, I am using sum of roots, product of roots. So if you do this, you will get alpha plus beta is, no, sorry, alpha beta is not minus 8 by 5. If you cut the minus 2, it will become 4 by 5. Alpha beta, oh, Abhi has gotten the answer already in chat. So alpha plus beta is, maybe you're right, Abhi, just a minute, minus 1, 1 minus 9 by 5. So it is like minus 4 by 5. Oh, alpha plus beta is minus 4 by 5, alpha beta is plus 4 by 5. Okay, so then we know x square minus 4x plus 4 with a 5. 5x square minus 4x, not minus, plus 4x plus 4. Yeah, that's correct. Yeah, you can also use distributive law, that's correct. Naban in chat is noting that you can also use distributive law, you're right. That's another way to do it. Once you've gotten the two roots, you can just multiply it out and compare coefficients. That's another way. But either way, it's an easy question. Like, main point is 5, 4, 4 is ABC. So again, I'll make mistakes, but 5 square plus 4 square minus 4 square, okay, is I guess the answer. So answer is 25, right? Tell me I did it correctly. Hopefully 4 square minus 4 square is correct. Okay. So I hope people got this in the exam. Okay, 25th problem. In the adjoining figure, POQ is the diameter of the semicircle with center O. OABC is a square whose area is 36 centimeters square. Okay, let's see. Adjoining figure, you have POQ is the diameter of the circle, semicircle center O. OABC is the square whose area is 36 centimeters square. If QD is x centimeter, what is the value of x root 3? Okay, they have given us QD and they have given the area of the square, which means they have given us the side actually, right? They have given us this is 6666 and they have said O is the center of the circle. Okay, and then they are asking us what is the length of this fellow. Okay, cool. So how will we tell essentially? So basically, if I knew this was 6 centimeter and this was 6, this also 6, you can, I think, solve it by putting x and everything, and then wait a minute, what is the main point here? This is the center of the circle. This is whatever, some random thing. It's not the radius of the circle. This is the radius. This is 6 plus x is the radius. How do you solve this problem? Let me think. Can we just assume the radius is r and then from there figure out? Because if once we get the radius r, we are done, I think, right? Because then we know this and then we know this angle, then we can get the chord length. Or is there a power of a point thing? CD into CQ is the distance from, what is CD into CQ? But again that also requires a radius, but then that requires CD also. We want CQ, DQ though. Oh, I see, that's correct. Oh, it's a diagonal. Yeah, B, you're right. Pradyun is also right. Yeah, the diagonal is 6 root 2. We know, so it's okay. Correct. Missed it. So the diagonal of the square is 6 root 2. So therefore that is a radius. So we are done. So you know 6 root 2. So you know this is 6 root 2. And the sine theta is root 2, for instance. That also we know. So this we know is sine theta is root 2. So we should be able to calculate this now. This length. QD. If you want, you can calculate this height maybe. How do we calculate after that? Is it not yet over? So no, this we should know now, right? You have essentially this length. This length is known. This length is known. And just a minute. So if you drop a perpendicular here, we're done, I think, right? We're done. Because what you do, okay, I'm going to do this. I don't know if you guys did it. You drop a perpendicular. This is theta. Sine theta is 6 by, hopefully it's visible, 6 root 2. So 1 by root 2. So once you get sine theta is 1 by root 2, then you can basically do 6 root 2 cos theta. That is half of dq, right? So we're done. So cos theta is, if sine theta is 1 by root 2, what is cos theta? Cos theta is also 1 by root 2. It's 45 degrees. So essentially you will get 6. So this answer is 6. And so answer is what, 12? No. Did I make a mistake? Okay, mistake is not. Why have they given? Oh, they have not asked CD. They asked QD. No, that's correct. If QD is X, why are they getting in terms of root 3? You know, I guess they're supposed to get a root 3. Sine theta. Did I make a mistake? Let me repeat. So join OB. Wait, OB 6 root 2, no? First of all, let me see. I make arithmetic mistake a lot. So the square area of the square is 36. So sides are length 6, right? Then radius of the circle is 6 root 2. Correct? Radius is 6 root 2. Once radius is 6 root 2, see what you guys can tell me if I'm making a mistake. So this radius is 6 root 2, OQ is 6 root 2 because it's a semicircle. Once you get OB is 6 root 2, we know this height is 6, right? So, oh, I see, sorry. I made a mistake. No, yeah, I made a mistake because of the following. Fine, got it. So if this is theta, then this is 90. Tan theta, not sine theta, that was a mistake, is 6 by 6 root 2. So tan theta was 1 by root 2. So this is like, okay, so tan theta was 1 by root 2. Now drop a perpendicular. Yeah, it's done. Now we drop a perpendicular. So you'll get that half of dq, half of qd is 6 root 2 cos theta. Cos theta is, if tan theta is 1 by root 2, this is root 3. So cos theta is 1 by root 3. The cos theta is, what is cos theta? Root 2 by root 3. Okay. So you essentially get QD is 6 into 2, which is 6 into 4, 20, 6 into 2 into 2, which is 24 by root 3. So did you guys get 24? What is the answer you guys got? Okay, somebody might have written in chat already. 24? Yeah, you can use Pythagoras theorem. I'm just trying to use trigonometry. Yes, answer is 24. Yeah. Okay, so I think you can use like either way here. You can do it by Pythagoras theorem also. All I did is I dropped a perpendicular from O to dq and it cut the chord into two equal halves. So I just had to calculate one half of it and then I had to multiply by 2. But I can calculate this small piece here because I know this angle theta and I know this hypotenuse is a right angle triangle. I know its hypotenuse, I know tan theta is 1 by root 2. So from there I can calculate what is cos theta essentially. Then I computed it. But you can do it by Pythagoras theorem. I mean, after all, lots of trigonometry identities are essentially Pythagoras theorem, right? It's the same thing. It's Pythagoras. I mean, I think trigonometry is like a way of thinking. Idea is the same. Okay. Okay, it's not visible. Wait, if A is root 2024, B is root 2025, some ugly thing, what is this? Okay. So, let's just see. I think it's not worthwhile to put 2024, 2025 there, just n plus 1 and n or something. Maybe better to just put a square is n and b square is n plus 1 and just essentially maybe play around with that. Or maybe even simplify this first. Root a by b minus root b by a the whole square is a by b plus b by a. This is some boring algebra, I think. A by b. They were like, there's no enough algebra question, so let's put an algebra question. Minus 2 root a by b into root b by a will cancel. And then become 1/4, right? And then you add 1 to it. So what do you get? A square plus b square plus 4ab. Oh, looks ugly. Oh, no, there's a 1/4 outside also, right? Wait a minute. I should not be hasty. There's no space here to scribble. But it's 1 plus 1/4 a by b plus b by a minus 2, right? And if you simplify this, you will get a by b plus b by a, because I know they can't give really complicated things, you can't simplify. So I am sure I made a mistake. So a by b plus b by a by 4, and then there's a minus 2 by 4, it's minus half. Minus half plus 1 is plus half, so you'll get like 1 by 2. And then you will see that it will be a square plus b square by, there's a 1 by 4 here. Okay, so you'll get 1 by 4 if you take common out, it will be this plus 2. So you'll get, I think, a plus b the whole square by, or basically it's root a by root b the whole square. It's, I think, essentially 1 by 4 if you take out. It's just, okay, solid. Actually, I can simplify and tell you what it is. You guys do the algebra yourself. This expression here, I'll tell you directly what it is. I just did the algebra. It is actually nothing but root a by b plus root b by a the whole square. That's all. Just complicated it. Okay, expand it, you'll get this. Its square root is just root a by b plus root b by a. So what remains is, when you take the square root, this will remain now. And outside, you have some root ab by a plus b, which if you take common denominator, everything will cancel. The answer is what? 2. Didn't matter what root 2024. Oh, okay, outside the screen. Is it visible now? Yeah, the answer is 2. Everything cancels out. Everything. You are right, Abhi. Yeah, you're right. Everything cancels. Just all this root 2024 was just time pass. Just some boring problem. Artificially constructed problem where they just made up some expressions. Yeah, so anyway, hopefully the screen is very awkwardly placed. I don't know what to do about this. So let's see, does it change? Okay, I don't know. Okay, hopefully the screen is visible now. Okay, next question. In a decreasing geometric progression, the second term is 6. By the way, I hope the ones who wrote it who are in chat got this problem 26. You didn't leave it because it's such a easy problem, except that just unnecessary mess they did. in this question. Hopefully you got it once you wrote this exam. Answer is 2. Okay. Alright, anyway, let's move to 27. In decreasing geometry progression, the second term is 6. The sum of all infinite terms of the progression is 1/8 of the sum of what? Second term is 6. The sum of all infinite terms of the progression is 1/8 of the sum of infinity of the squares of the terms. The first and the fourth term is p by q. Then value of bracket p by q is okay. So I guess there's some formula a plus a ar plus ar square dot dot dot, which is a by 1 minus r, right? That is basically the sum. And if you square everything, then it's again a geometry progression. So you'll get a square by 1 minus r square. And as long as a is not 0, so it's decreasing geometry progression, and r is not 1, that's why they have given as decreasing. They don't want r to be 1. You can cancel on both sides and get a by 1 plus r. So you get basically a is 1 plus r, right? So once you get a is 1 plus r, what is the second term of the sequence? That's easy to get. If second term is 6, the second term is a into r, so it's a into r is basically r into 1 plus r, which is 6. And if r is 2, this works, right? 2 into 3 is 6. That's one way of getting, but it should be decreasing geometry progression. R can't be 2. So this is the other root, I think. What's the other root? R square minus r square plus r minus 6 is equal to 0. The other root is 2 and minus 3. Make a mistake. Is it visible? Oh, it says 1/8. Yeah, thank you. So as Pradyun notes, it says 1/8. I missed the 1/8. So the sum of all the terms a by 1 minus r is 1/8 of the sum to infinity of the squares. Okay, so a square by 1. Thank you. So you cut a 1 minus r with 1 plus r. You will get, yeah, thank you. So you will get 8 into 1 plus r is a. Okay. So ar, which is r into 8 into 1 plus r, is 6. Second term. So now you will get basically r square plus r is 3 by 4. And r square plus r equal to 3 by 4, r equal to half will satisfy, and it will be decreasing. So that should be a valid solution. So r is half. Okay, r is half. And if you put half here, you will get 3 by 2, which will be 3 by 2 into 8, which is 12. So a is 12. Indeed, a is 12 and r is half, second term is 6. Okay. So now you can see that the sum of the first and the fourth term is p by q, it seems. First term is 12. The fourth term is 12 into r cube, 12 by 8. 4 2s are 4 3s are. The sum of these two is some weird complicated thing. 12 plus 3 by 2 is what they are looking at. 27 by 2. So p by q is 27 by 2. Was there a problem? They were given 1 by 8. Yeah, correct. You're right. I'll be sorry. That was a mistake I made. So did you guys get 13? 27 by 2's greatest integer function is what? 13. This is 13. Hope that's correct. Sum of the first and the fourth term. Yeah. Correct. Yes. Very good. Answer is 13. Okay. Now we can try to move ahead. Oh, we are towards the end of the paper. Oh Lord, can't forget the geometry progression formula, guys. A by 1 minus r. So you should know it. A. There's like so many questions asked on it. Like quickly, since IOQM is coming up, a plus ar square plus dot 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 is a by 1 minus r. In fact, that a you can multiply everywhere. The a you can multiply everywhere, so you can just write it as 1. Okay, it's out of the screen, so let me just all right. So, and one, sometimes the so-called arithmetic geometric progression is also useful. Okay, sometimes the arithmetic geometric progression is also useful, which if you differentiate you will get, that is 1 plus, if you differentiate 1 it's 0, differentiate 1 r it is 1, r square it is 2r, 3r square, 4r cube dot dot dot. This summation is 1 by 1 minus r the whole square. This also is useful. You can further differentiate this if you want to get 2 plus 3 into 2 into r plus 4 into 3 into r square dot 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 2 by 1 minus r cube. Anyway, but I think this may be not so much. Sometimes it's useful, but these two are certainly very, very useful. And by the way, this works only if mod r is less than 1. If mod r is not less than 1, it won't work. And the other formula that you need to know for this is called AGP, and so there is another formula you should know about arithmetic progressions: a plus d plus a plus 2d. Yeah, thank you. It's out of the screen. I am bringing it back, and I don't know why this weird screen issue is happening actually. So if you take this summation, okay, I don't know which part of the screen is cutting off actually. Yeah, no, it's awkward. Okay, so if you write this, you will see that this is n. I hope you guys know this. This is the formula for the sum of first n terms of an AP. It's n by 2 into 2a plus n minus 1 into d by. Sometimes people write it n by 2 into the first term a plus last term. Okay, so again I'm scrolling stuff up, so just so that you can see it. So okay, right. Okay, so these are like some kind of basic formulas you should know. Just again revising quickly, if you're writing the exam, summation k varying from 1 to n is n into n plus 1 by 2. Summation k square k varying from 1 to n is n into n plus 1 into 2n plus 1 by 6. Summation k cube k varying from 1 to n, just make sure you guys know this, don't say you don't know, whole square. Okay, there are some other set of basic formulas. Very funnily, I want to do some stream where I teach you guys fun powerful applications of calculus, maybe after IOQM, where if I ask you what this is, infinite sum, this is pi square by 6. See this, but this is just a joke. I don't think this is out of IOQM syllabus. Oh sorry, again it's out of screen. I think this is, it's out of screen is annoying me. Okay, I think I should cut off. Right. Alright, so anyway, so that we are towards the end of this calculation. So let's go back. As Abhi says in chat, it's right. I don't know whether it's out of IOQM syllabus, but it's out of screen for sure. So problem number 28. So let's go back. All right. So what is this? Oh, log questions. Log. More like lol questions. So the value of root 10 by 10 power log 9 base 10 minus 2 is of the form a by b. So it will be like some boring thing, 10 power minus half, and half meaning 2, 2 meaning log 3 times. It's silly, right? It's very silly. I'm trying to see which part of the screen is visible. Okay, so root 10 by 10 is like whatever, 10 power minus half log 9 base 10 minus 2 is 10 power minus log 9 base 10 is like 2 log 3. Oh, that's it. Yo, 2 everything will cancel. Log 3 base 10 minus 1. Then we are done, right? 10 power minus log 3 base 10 is 1/3 by 10. So what is the answer? Is 10 by 3. What is it? Answer is 7. Yeah, that's correct, as Abhi notes. Chat already has solved it. Okay, problem 29. ABCD is a square. Okay, BE is tangent to so many semicircle problems. Third or fourth one in now. Okay, BE is tangent to the semicircle on ADS diameter. Area of triangle BCE is 216 centimeters square. The radius of the semicircle is ABCD is a square. Okay, BE is tangent to the semicircle. The area, what is the radius? Let's see. So we have solved these kind of problems before, I think. We have solved it, no? So this is R. I mean, sorry, that's not R. I mean, calling it R is not a good idea. I mean, if you take this length x, this length as x, then this length is x. Again, tangents are equal in length. I think this is some standard problem, no? We've done this before, I feel. This is like y. This also is y. Oh, y is the side of the square. So this also is y. Since y is the side of the square, this is y minus x. So we have now a nice relation between the Pythagoras theorem and area of triangle. So we should be able to solve the problem, right? Maybe there's a shorter way, I don't know. Pythagoras area of triangle is half into y minus x. So y square is like 4yx. Y is not 0. I hope the square is not 0 side. So y is equal to 4x. So we have y is 4x and we know the area of the triangle. So this is 4x and this is 3x. So half into 4x into 3x is maybe it's faster to just work with y because we want y, right? We want the radius of the semicircle, which is y by 2. Tricky. So we want y by 2 anyway. So we can say maybe we should calculate 4x, 3x. It doesn't matter. So this is 216 and 2 2s are, so 6 will cut. So x square is 36. So x is 6. If x is 6, then y is 24. So this is 24 diameter. So radius is 12. 12? Done? Is that what you guys got? Okay. So this is some standard question, right? It's there in, I think this is there in, some variant of this is there in David Altizio's famous, like I like to use that as an intro. If you're new to geometry, like you just want to practice these kind of questions. There's that David Altizio's set, right? If you search, I think if you search you'll get it, like some lots of geometry problems. Right, here's a nice collection of, I think, angle chasing. There's a set called angle chasing. Then there's 100 geometry problems from AIME to SM or something like that. I forget. I think one of those sets has it. Okay, this question, it's not new. All right. Anyway, so let's. Yeah, I'm also getting 12. Abhi. Okay, last question. A, B, C, D are real constant. And in f of x is ax per 2025, bx 2023, cx 2021, dx 2019. F of minus 4 is 18. the maximum value of mod f of 4 plus mod 2 cos x is. Okay, let's get rid of the log question. So many log questions are so easy to get, right? I mean, either they're easy or the algebra is too hard or something like that. Okay, ABCD are real constants in f in some expression which has all 2 powers of f of minus 4 is 18. What's the maximum value of 20? Wow, okay, it's too fast. As Abhi is saying, answer is 20 for the last one. 2 cos x. So what is the point here? Minus 4 for 2025 a minus 4 for 2023 b minus 4 2021 c minus 4 for 2019. Maybe I should not have even written it. 18. So the maximum value of plus 4 per 2025. Oh, okay. I see. You can just take mod basically. That's it, right? I mean, basically, if you take mod of this expression, it is still 18. Basically, f of 4 is essentially minus 18 because it's an odd function. All powers are odd. So it's an odd function. F of x is f of minus x. Because of which f of minus 4 is 18, then f of 4 is minus 18. That is certainly true. So mod of that is 18. And the maximum value of x is, cos x is 1. So it's just some silly thing. It's just 20. Yeah, correct. Done. Okay, so which questions here were hard actually? Guess most of these were doable, right? Most of these were doable. This one I fumbled because I didn't notice the diagonal being the radius for a while. You guys told me. I done calculation mistakes here, but there's nothing that was hard. I think it's tan A plus tan B plus tan C, this relation people didn't know, so they lost. But what about others? Okay, there was one question which was undoable, if you guys remember this one. I think this problem is bonus, I think. We're done. Cool. Okay, so I don't know if you guys have the energy, but we can do a little bit of 10, 11, 12 NMTC as well. More fun questions. So we are done with the basic one, and now we are looking at the more harder questions. I guess this is 11th and 12th standard inter-level NMTC, and Abhi had shared this with me. So okay, so for each incorrect response you lose half. Okay, I mean some of their questions are wrong sometimes. Yeah, so let 1 half 1 by 3 up to 1 by n. What's the highest power of 7 that divides m? Oh, this is Wilson's theorem, is it? Sounds like the setting for Wilson's theorem. 6 factorial is minus 1 mod 7. Highest power of 7 that divides m. Answer is what? If you, actually in this case you can just really multiply it and check. It's not like too big also. Right. So let's see. 1 plus how do we realize what's the highest power of 7 that divides? I mean, certainly if you go modulo, 7 is prime. So 1 by 1, 2, 3, 4, all reciprocals again in some order will be 1, 2. So 1 factor of 7 at least will divide. At least 1. Answer is at least 1. That is immediate to me. But does 7 square divide it? Can I directly tell without doing the full? Actually, see, obviously we all can do the direct computation. We can just really add it up. But is there some way we can do this in a better way? What would it mean actually? If you go mod 49, is it helpful? Yeah, it seems like it's like, I mean, dividing by 7, I mean, 1 factor of 7 is definitely easy, right? I think it's some general theorem. Wolfen's, what is it called? Wolfenholm theorem, something home, Wolstenholme theorem, something, I don't know. It tells you 1 plus 1 by 2. It talks about 1 by 3 up to 1 by p minus 1. Certainly the numerator is divisible by, this is obviously p minus 1 factorial, then you take common denominator plus and a numerator. Then it talks about numerator being divisible by something, p cube maybe, or at least p square. I think you guys have done it by hand, right? So it must be p square. But could we argue, it's very trivial to check it's divisible by p, right, as I told you, because go mod p. If you go mod p, it's essentially a field, meaning all the reciprocals exist in modulo p world when p is prime. So all the reciprocals are just essentially numbers 1, 2, 3, 4 up to p minus 1 in some other order. So this is 1 plus 2 plus 3 up to p minus 1. So you'll get p into p minus 1 by 2 essentially when you sum it up, and that's divisible by p for sure. But so why is it divisible by p square? Wolstenholme's theorem, yeah, correct. Wolstenholme's theorem. What does it say, Avi? Do you know what's Wolstenholme theorem say? Does it say p square? P square divides n. Is that the general theorem? I think there should be some clever proof of this other than calculating by hand. Now, what if they gave you for, a very large prime which you couldn't do by hand, like it gives p square. Okay, from Wikipedia it says p square. Right. Okay, so I think worth knowing, guys. 1 plus 1 by 2 plus 1 by 3. It's a theorem really because it's stronger than whatever we observed. N by p minus 1 factorial, when p is prime, p prime, then p square divides n, the numerator. I remember the number theory book, some number theory book I read having a very cool proof of it. Is this some, can you guys see what could be the proof? If you do 1 by p here, if you do 1 by p, no, that's not useful, I think. If I do 1 by p, 1 by p, and 1 by p, can you do some telescoping or something? Can I prove that this sum again is divisible by p? Then we are done, right? If I divide by p and still the numerator is divisible by p, then I would be done. But I can't go modulo p now because I divide by p. Yes? Okay. I think it's 1 by p plus, if you do 1 by p minus 1 by 2, p minus 2 by p, I don't know, or some differentiation or something. X, sum of roots, product of roots, can I use x minus 1 into x minus 1 by 2 plus x minus 1 by into x minus 1 by 3 factors. Okay, I can't recall. Alright, so let's move on. I think it's a fun question though. Can we use CRT? Maybe not here. I don't know how to do it. Okay, so let's say you did it by hand. Next, 5 spherical balls of diameter 10 each fit inside a closed cylindrical tin with internal diameter 16 centimeter. What is the smallest height of the tin that can be? Okay, 5 spherical balls of diameter 10 centimeter, which is essentially 5 okay, so 5 spherical balls, radius is 5 centimeter, 4 by 3 pi r cube is the volume. Maybe it's just the volume count, right? What's the smallest height? Actually, it'll always leave gaps. Are they being careful about that? It'll be tricky if you. First of all, the diameter is 10 and internal diameter of the cylindrical tin is 16. So you can't even have like two things that can fit at the bottom. So only one thing can fit essentially, right? Like if it was the internal diameter was 20, then maybe two things can fit. Yeah, so one would think that the smallest height has to be this is complicated, I think, right? How do you calculate that? How do you calculate this? If you have like this, the next one will not fit, but it can go down like this. How will we calculate it? It's a little complicated, no? You can't blindly do volume idea also, I think. Well, you can do volume. But the height is not bounded by the sum of the. How do you guys calculate? I mean, you have here. Let's say you place it here. Then like this here. Like this. Like this. Like this. We get a chord of length 6. Chord, which chord? Sorry, which chord are you talking about? To calculate the height, yeah, we know the radius, that is true. So I guess this repeats, maybe that's what you guys are saying, right? So this pattern repeats. Yeah, you can calculate the, I mean, I'm trying to calculate, I guess, yeah, to calculate the height, you have to calculate, that's correct. I guess we can, that's true, we can repeat the pattern actually, right? So you're right. So I'll be saying that it was the answer was not there in the option. So there will be like something like this, and there will be something like this. How much does it go? The only condition we have is that this is tangent, and then this is tangent and this is tangent repeatedly, right? So we'll keep getting layers like this. So every unit we will get one height and one more actually. Yeah, we can finish off the calculation, I think, like this. So then we can compute like what is, since we know the height, yeah. So basically we know this width is 16 centimeter diameter, and we know this ball of this spherical ball has diameter 10 centimeter. So this is for radius 5. So if you have like this, can we calculate? This is 5, this is 10, this is 5, and this is 5. So can we calculate what is this height now? I think we should be able to, right? So if you calculate this, you should be able to calculate what that is. How will you calculate the height? like this. I guess, is it by symmetry these two are equal in length? So this is like, this is 10 and this is like 10 by root 2 and 10 by root 2 or something like that. It's 5 plus 10 by root 2. I'm guessing by symmetry actually. So, oh, but you can't say that. Oh, I see, I understand. So because this total width also is limited, I have to use this as 16. Yeah, thank you. Oh, Sanvi didn't got the answer. Oh, I see. Okay, that's what we meant. So this is 16. This is 16. And if this is 16 centimeter, okay, and I think this is a good question. So see, this is 16 centimeter. This is already 5. And this is again another 5. So 10 is gone. So in between, the distance between the center is 6. Ah, nice. What a nice question. 10. This is 6. This is 8, therefore. So this height is 8 between the two centers. So whenever this happens, the height between the centers will become 8. Next again 8. This height is 8. So this is like 8, 8, 8 and 8. Okay. So 1, 8, 2, 8, 3, 8, 4, 8 and then the remaining 5 and 5. 4 8s are 32 plus 10, 42. Answer is B. Correct? Did everybody get it? Essentially this is 16. Okay. But this height is 5. This distance is 5 because this is the radius on the top. It's tangent, no? So this radius must be this distance. So this is 5 units away, this touching point. And this, if you drop a perpendicular also, is 5 units away. So now on this base now, if you drop here, this is 5 units here. This is 5 units here. So what remains distance between the center? The two centers is totally is 16. 5 and 5 go away. So what remains is 6. So distance between the center is 6. And this is 10. Hypotenuse is 10. So it's a 6, 8, 10 triangle. So the height is 8. So the height between the centers is always 8. 8, 8, 8, 8 heights. Okay? Perpendicular heights. Very nice. So it's 42. Okay, I like it. So I think in the chat somebody said Sanvi got it. Okay, and got it. Should she get 42? Yeah, I hope so. Okay, cool. Alright, so now what about the next question? The expression 7n, oh man, such a standard expression. 7n plus 18 by 2n plus 3 takes integer values of certain value of n, the sum of all such values. This is such a standard question. Some questions are like repeats in life, right? So how do you do this problem? 2n plus 18, 7n plus 18 by 2n plus 3 takes integer values for some certain values of n. So one thing you can do is, like, if it takes integer values, if you do 2 times also it should take integer values. So 14n plus 36 by 2n plus 3 is also integer. The benefit of multiplying by 2 is, like, now 2n and 14n you can sort of cancel. So you can write this as essentially 7 into 2n plus 3, so 21 plus 15 by 2n plus 3. Standard trick, 7 plus 15 by 2n plus 3. Now you see, 2n plus 3 must divide 15. That pretty much limits what 2n plus 3 can be. And you try all those values, that's it. 2n plus 3 should divide 15. So 2n plus 3 can only be, well, let's say certain integer values. So okay, then it will increase the chances, but 2n plus 3 can only be 1, 3, 5, 15 or, but that's still quite a bit, or plus or minus 1, plus or minus 2, plus or minus. But whatever it is, will it not just add to, do they mean positive integer values? No. Say, maybe some of those values will not work because, when you plug in 7n plus 18 by 2n plus 3 will be half integer, because when I multiply it by 2, I made actually certain half, if this were half integers also, when I multiplied by 2 it would have become an integer, right? So there will be some spurious solutions from this technique that I am using. Nevertheless, we can try though. I mean, you guys know what to do now, right? So 2n plus 3 can only be plus or minus 1, plus or minus, not plugging in. Okay, so let's see. I mean, if n is, well, all these are odd, so there's no issue, it will work. So n is equal to 2n plus 3, 2n is minus 2, n is minus 1, in which case plus 1, minus 4, n is minus 2, n is 0, n is minus 3, plus 5 is 2, n is 1, minus 5, minus 8, minus 4, n is 12, 6, minus 18, minus 9. So these are the possibilities, too many possibilities to try. And I hope not all are true, because when you plug in, obviously you won't get negative values, right? Answer is all positive. So if you plug in n is minus 1 and all, it may not work. 18 minus 7 by 3 minus 2, it works. Minus 1 works. So which ones work? Minus 4 plus 3 is minus 1. Okay. It's again out of screen, is it? Okay. Thank you. Okay, can all of you see the calculation? Sorry, I keep it's weird out of screen thing. All right, so just too much boring case work for me to do. Okay, but let's finish it off. So what is, but I'm getting like negative values. So sum of all such values of the expression is, oh, the expression has to be summed. Okay, very painful. So n equal to minus 1, when I put, the answer was, I didn't keep track. 18 minus 7 was 11 by 1. So it was 11. When you put minus 2, it is minus 14 plus 8, which is 18, which is 4, divided by minus 1, this is minus 4. 0, if you put it, is 6. It's too many cases. Is there a shorter way to do this? Minus 21, 18 minus 21 is minus 3. Put n equal to minus 3, what do you get? 2 into minus is minus 6 plus is minus 3. And if you put minus 3 on the top, it's minus 21 plus 18, which is another minus 3. I mean, I'm more prone to making mistakes actually. It'll be a surprise if I get it right. So 1 is 25 by 5, which is 5. Wow. So many integer values. Minus 4 is minus 28 plus 18, minus 10. And minus 4 into 2, 8. Minus 8 plus 3, minus 5. Wow, 2. And let's erase this. And let's write here. I hope it is still visible on the screen. Okay. All right. So my 6 will give me 6 and 42, 50. Now it will not. 50. 6 2s are 12 by. Oh, 6 doesn't work, is it? 6 and 42. Oh no, 60. 60 by 12 by 15. By 60 by 15, 4. Was there a shorter way to do this? Did anyone do it by something other than brute force? Minus 63 plus 18. Minus 53 minus 40 minus 45. Divided by last one. Should not give up now. Minus 18 plus 3 is minus 15. It's plus 3 actually. Okay. Since I got everything positive except minus 4, I'm a little worried. It's minus 2 correct, giving you minus 4. Minus 4, 3 minus 4, minus 1 at the bottom. Yeah, it does work. Yeah. Alright. So what is the answer? Looks too big. 4, 7, 7, 9, 14 plus 1, 15 plus 6, 21 minus 4, 17, 28. So did anyone get 28? Problem number 4. Yeah, oh great, yes, somebody got, indeed Dub Boy says he got it 28. So problem number 4, P is a point ABCD such that PA is 2, PB is 4, PC is 5. I'm actually proud I got it because I make so many arithmetic mistakes. P is a point ABCD such that PA is 2, PB is 4, PC is 5, PD is 6. The maximum area of the quadrilateral is. P is a point inside the quadrilateral. Isn't this an old IQM question or PRM question? There's a triangle, there's a quadrilateral ABCD, there's a point inside, and its distance to the vertices are given to you 2, 4, 5, 6. What is the maximum area of the quadrilateral? Oh, it is in my rotation mastery. Wow, okay, cool. So let's see. Oh, that means you should be able to do it by rotation, right? Okay, but is there a more simple way to do this? Yeah, it's a inter question though. So I should not make it look like a. A, B, C, D, P, P, A, B, B, P, C, P, D. How would you get the maximum area of the quadrilateral? We can do one thing though. I don't know whether you can do by rotation mastery, but you can certainly do this by putting angle made at the point P as A, B, C, D. A plus B plus C plus D is 360. And then you can say like half sine A sine B kind of a thing, like half PA, PB sine A, blah blah, whatever, sine theta. So you'll get something like you have to maximize. You get some nice constraint. I don't know whether, I mean, it's not a pure geometry solution. It's like some kind of trigonometry mixed solution, right? Like you can angle APB is like theta and like theta 1, PPC is theta 2, CPD is theta 3, APD is theta 4. Angle made at the corner P, I mean as a center at whatever that point P. And you know, area of the triangle in terms of trigonometry is half into the two sides, length of the two sides into sine of the angle in between. So you want to sort of maximize the sum. So the maximum value of sine theta is like 1. If you can make all of them 1 and satisfy the constraint, great. Sine 90 is 1. Yeah, as Abhi notes in chat. So we are done. So you want to make all of them 90. So that's it, right? So it's half into PA into PB plus half into PB into PC plus half into PC into PD plus half into PD into PA. That's it. So it's 2 into 4, 2 into 4, 8 plus 4 into 5, 20 plus 5 into 6, 30 plus 6 into 2, 12 into half. That's the answer. So the answer is 28 plus 30, 58, 70 by 2, 35. That's correct. Okay, which by the way is the answer I see here. Yes, the answer is just that. Cool, nice problem. I don't think you need any rotation for this problem. I think there is some 2, 4, 5, 6 kind of problem in rotation mastery, I remember, but it's something else, I think, some other length you have to compute. Nice problem, right? Okay. Problem number 5. The value of 3 power a by 3 per n by 3 plus 3 minus 3 per n by 3 plus 1. right? I think this is like some kind of 3 power n by 3 minus 3 power n minus 1 by 3, no, n by 3 minus 1 summation square. I think I can take 3 power n by 3 common out basically, and it will become 3 power n, and what will remain will be common. That's it. So 3 power n by 3, if you take common, it's 3 power 2n by 3. Oh no, per cube is it? Sorry, you notice per cube. So it's even better. 3 power n will come out, and 1 minus 1 by 3. 1 minus 1 by 3 is 2 by 3, so it is 8 by 27. So it's 3 power n into 8 by 27 summation, written in some fancy looking way, right? And then there's just geometry progression. That's it, no? 3 power n, n by 3 starts from 1. No, in the way I have written, n by 3 starts from 4. Maybe I should have written the other way, okay. N by 3, n starts from 4 and ends at 10. So what do we get? What's the answer? 8 by 27, 3 power 4 plus 3 power 5, 3 power 10. So this you can write, you can cancel off the 27 below. 3 plus 3 square, 3 cube, 3 power 7. Yeah, I might have made a mistake though. How come the answer doesn't seem to have 3 power 8 minus 1 by 2? I'm getting 3 power 8 into something. Ah, there's a 12 outside, is it? Okay. 3 power 8 minus 1 by 2 minus 1. So that will be 3 power 8 minus 3 by 2. That's it, okay. 3 by 2 into 8, which is 3 power 8 minus 3 into 4. Now I can take that 3 common out and write 3 power 7 minus 1 into 12, which is 8. Correct. So what was required for this problem? Just noting that, writing the general expression as 3 power n by 3 minus 3 power n minus 1 by n by 3 minus 1, and then noting that n by 3 power n by 3 is common here. You can take it out with the cube and it will simply become summation of a geometric. So some very standard stuff. Okay, 100 people are standing in a line. They are required to count off in fives, 1, 2, 3, 4, 5, and so on from the first person in the line. Anyone who counts 5 walks out of the line. The remaining repeat this procedure until 4 people remain in the line. What was the original position in the line of the last person to leave? This is like Josephus problem, but written in a row. Interesting. Josephus is done with a circle, right? Okay, it's like a circle only. It's like standing on a circle, right? One is standing in a row. They count. Anyone who counts 5 walks out of the line. The remaining repeat the procedure. Not exactly. Not exactly. Right. So, oh, by the way, the Josephus problem. The Josephus problem is this, I don't know, that maybe a fictional problem about some 100 prisoners standing in a circle, and I guess in various, there are various, there are variants of it, but there are many variants, but one of the variants would be that some commander starts killing off the prisoners alternately in a circle, like kills the first person, then the third person, then the fifth person, and so on, or second person, fourth person, and until every alternate person he keeps killing, okay, until finally, if you keep doing this, eventually only one person will survive, right, because every alternate person will kill. So the question is, who survives? This is a very famous fun problem actually, and you can solve it by recursion. Don't look it up, don't look up the solution, just try to solve it yourself. You can sort of, it's really a fun problem to solve actually. And there is a easy sort of answer, like not easy, like there is a way to explain what the answer is easily using binary. If you can solve it. Okay, anyway. So, but that's they are standing in a circle. No, they just, here I think the way, at least in this question, the way it is written is 100 people are standing in a line. You keep counting in fives, and people who shout 5 leave the line. And at one point, I mean, basically, obviously at 95, they'll say 95 and they'll leave the line, and the person 100% will say 100 and leave the line. Right? No, is it anyone who counts 5? Oh, only anyone who counts 5 walks out of the line. I thought multiples of 5. Okay, okay. Anyone who counts 5 walks. This is easier, I think. So basically, they again repeat. So the sixth person will count 5 and he'll leave the line. They restart the count. This question is easier than Joseph's problem, obviously. Here 1, 2, 3, 4, 5, 6 dot dot. The person who says 5, count in 5s. 1, 2, 3, 4, 5, so on. For the first person. 100% standing in line, they are required to count off in 5s. 1, 2, 3, 4, 5, so on from the first person. Correct, multiples of 5. Multiples of 5 here also. So again, the sixth person will say, fifth person will leave. Then the sixth person will say 1, seventh person will say 2, and all the way up to 10. 10th person will say 5 and leave the line, and so on. Yeah. You guys are right. 95 will leave the line. I think that's what it meant. And then 96, 97, 100. Then they restart the procedure. Now 6 will leave the line. 7, 8, 9, 12 will leave the line, and so on. They'll keep happening until only 4 people survive. So what did you guys do? Really do all the 100, is it? Sit and like keep cancelling off stuff? Oh, 100 dots and, oh, okay. So armed by the, yeah, okay, fine. What is the idea? You start from the back. Back meaning, how will you know which numbers will survive? How does that mean? I'm not sure, Abhi, what you mean. But wait, let me think about this. Can we do it in base 5? In base 5, is there a pattern? Sorry, Abhi, I'm just doing something else than what you're saying. 9, 10, 11. Let's write the first few numbers. 13, 14, 15, 16, dot. In the first round, all the fellows multiples of 5 will walk out. In base 5, who are these numbers? These are the numbers who have last digit 0. Like 5 is 1 0 in base 5, 10 is like 2 0, 15 is 3 0, and so on. So all the fellows who have last digit 0 in base 5 will walk out. By the way, 100 is like 25 into 4, 400, 400 in base 5, 155 square, yeah. So basically, they'll walk out. Next, again, they will start. Then they'll be like 1, 2, 3, 4. And this time, who will walk out? 6 is like 1 1, and 1 1 will walk out this time, right? Okay. 6 will walk out this time, and 7 8 1 2 3 4 5 12. 12 in base 5, how does it look? Looks like 2 2 2, is it? 2 2 17 18 1 2 3 4 5. Now 18 is 3 3. So fellows who are like 1 1 2 2 3 3 are walking out. What is the pattern? That's some base 5 will help me. This one. Let's imagine we finished it. What's the next thing that will walk out? 1 2 3 4 7. Next 7 will walk out. 1 2, and 1 2 3 1 2 3 4 5. 13 will walk out. 13 is 5 2s are 10, 20, 23. So 13 and 23. Is there some, I think there's some base 5 pattern here. Yes, you could do it by hand though. At 30 they have a common factor, that's correct. 30 there's a common factor. Sorry, at 30, what is it? Sorry, what common factor will they have? 5. Wait a minute. If you did up to 25, what will happen? Is there some 5 1 2 3 4 will remain? Yeah, you can do it brute force, by the way. I mean, many are telling me by brute force they did and got the answer to be 96 or something. Maybe. 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23. It will go out of the screen actually. 19 20 21 22 23 24 25. And if you have 25 people, you go 5 10 15 20 25, then 6 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5 1 2 3 4 5. Oh, 22. Before that, 4 3 2 1 4 3 2 1. Okay, it's correct only. I'm thinking something's wrong. Okay, 7 1 2 3 4 1 2 3 4 5 3 4 5. Okay, 1 2 3 4 5. 1 2 3 4 5 1 2 3 4 5. Done, I think. 1 2 3 4 5. Only 4 people remain. So many people are saying 96. 189 1923. So Pradyun says 96. Many people in chat are saying 96. What is special about 1? I did this because I wanted to see if there's pattern among the ones who survive. What is 18923 in base 5? 1, 1, 3, 1, 4. I think there's no pattern. 1, 5 threes are 15. 4, 5 fours are 23. 1, 1, 3, 1, 4, 3, 4. Yeah, I don't know. So I think brute force only. I wanted to see some nice pattern. Because I remember it's like similar to the Josephus problem where you can do it in binary. There is nice pattern there. And for 5, for some reason the pattern is not working. I would have guessed for 25, the first 1, 2, 3, 4 only would have survived, but that didn't happen. I would have guessed for 25. Okay, in chat somebody is saying 98. What is the original position in the line of the last person to leave? The last person to leave that pattern something nice. There also should not have erased it. Who was the last person to leave? Luckily we have undo button. 13. In this case it was 13. Last person to leave. Is that a pattern? 3, 3. 3, 3 was lost long back. I think as Derboy says it in chat, like I think the correct way to do this is to reassign. And see what happens when you reassign actually every time. Should write down the transformation formula of who is the fifth number. I mean, which numbered people get transformed, and see how that transformation happens every time. Or rather, keep track of who's the last person. How is that moving? Maybe it's too complicated. So I don't know how to make this simple. Any other strategy did anyone do? I think Pradyun is saying he. How do you do? Okay. Brute force. Nabanu is also saying it's 98. So in chat, I think the question is how did 1, 2, 3, 4 get cancelled if we are repeating the procedure once we hit the last number? Oh, I did it like Josephus, I think. You're right. I went around. You're right, I went around. Anyone who counts 5 walks out. Those remaining repeat this procedure. What does that those remaining repeat this procedure mean? Do we again start from 1, 2, 3, 4 and then cut off the next guy? That's a different count actually, you're right. I think that's the one we agreed on, but then 1, 2, 3, 4 will always remain, right? So if you do it that way, 10, 15, 20, 25. Then again 1, 2, 3, 4. Next 6. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, now I don't know how it works. 1, 2, 22, 23, 24. 1, 2, 3. Well, if I go around in a circle, it will be 1. But I guess that if you are not doing, we repeat. Oh, they restart the count. Okay, then you're right. 1, 2, 3, 4, 7 will go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then we stop again and again restart the count. Oh, then everything after this will keep cutting, right? 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, then 9. 1, 2, 3, 4, 5. 1. Just a minute, Pradyan. So 22. Again we restart the count. 1, 2, 3, 4. Done. Then one by one everything will keep getting cut, because once you have no more 5 numbers, 13 will get cut. Next step 17 will get cut. Next step 19 will get cut, and the answer to this is 24. So what remains is one number less than 25. Oh, this is a different kind of a problem. What is happening here? So at the end of the day, if you look at, okay, so Pradyun is explaining some strategy he believes will work. So what is, anyway, but let me see for a minute. If you go up to 100, what would have happened? 5, 10, everything would have cut off. And again, you'll start with 6. And then you will keep cutting things. Then 7 and so on. What will survive? What pattern repeat? Shreyas says you got 99. There's no option 99, Shreyas. So 1, 2, 3, 4, 25. I think Pradyun has explained in detail. Okay, Pradyun, why don't you put it in YouTube chat? I want to try some other problem here. Let me think about this later. We'll come back to this later if you have time. So because, okay, maybe I'll try to read. Oh, you can't put it, okay. I don't know. Pradyun says every time the people are removed, the position of the person goes n less than its current position. What is the obvious pattern in chat? What is Nabani saying? What is 5x, 6x and then 7x? For 25, it's 20. For 96, what's the obvious pattern? First 5x gets terminated, that's correct. Oh, I see. First, all multiples of 5 got eliminated, that's correct. Then 6 got eliminated. Then 7, 8, 9, 11, 12. 6, 12. 1 2 3 4, yeah, yeah, one, it went one ahead essentially. Yeah, that's correct, that's correct. That's correct. 7x got eliminated. So first all multiples of 5 get eliminated, then multiples of 6 got eliminated. I see. But I guess at 30 we have to remove something. That pattern will fail later. What's so special about 30 though? Oh, I see. Okay. Let, what happens? Why 30 is a problem? We eliminate 30 in our 5 count, that is correct. Yeah, that is true. I think Pradyun is okay. Pradyun's strategy is that I think Pradyun's strategy is slightly different, right? So he's saying, from what I understand in chat, he's saying that you every time you basically, if you remove all multiples of 5, then you removed 20 multiples of 5, right? 100 people are standing. So basically, when you repeat the procedure, you have relabeled everyone. And what has happened is now there are only 80 people because 20 people have been removed. So the position of 99 becomes, I mean, as if you restarted the procedure with 1, 2, 3, 4 only numbered 80, where 80, the person numbered 80 really has a different label. The label is 99, right? So, and you keep doing this procedure. Now again 80 divided by 5 you cut. 80 by 5, there are 13 people you remove. But I'll have to keep track of who you are removing. All non-multiples of 5. I'll keep track of it in a better way. Because we have to keep track of who leaves last. So if maybe one thing you can do is you can reverse track if you do the procedure and check who are the ones that remain. Right, if you do 80 by next is 13, so if you subtract then 70, 67, then it's like repeating the procedure with 67 people and so on. But I guess it's not keeping track of the formula of who are the ones who will survive. I think if you, when you move from here to here, if you keep track of the formula of the labels, then it should not be a problem. But I guess it will get complicated if you keep doing it. Yeah, reverse track, yeah. But I guess Pradyun has done that actually. Okay, I don't know. So he's explained how to do, but not able to follow. He's put the, I think Nabanya has put Pradyum's argument in chat if anybody can understand it. Okay, so let's maybe move on. I want to do a few other problems. We can come back to this. So problem number 7, let's move on, okay? So I want to solve some other problems. The number of values of positive integers n for which 1 factorial plus 2 factorial plus n factorial is perfect square is. What is the answer? 1 is an answer. 1 plus 2 factorial is 3. 1 plus 2 factorial plus 3 factorial 6 is 9. 9 plus up to 4 factorial is 24 plus 9 33. And 120 if you add is 153. And if you add 6 factorial is 773 and so on. So actually you'll see that it always ends with 3 afterwards at this point onwards. There's no perfect square that ends with 3. Right? So which means these are the only 2 perfect squares. So just 2. Okay. Yeah. So that was easy. When 2025 power 2026 minus 2025 is divided by 2025 square plus 2026, the remainder is, what is this? I guess it's just modular arithmetic, right? 2025 square is minus 2026 maybe. Maybe do you want to just modular arithmetic maybe? Modulo, this is 2025 square is congruent to minus 2026 modulo 2025 square plus 2026, right? N is, basically n is 0 mod n, that's all I'm using. So if you go modulo this particular number n, it is 0 mod n. So therefore 2025 square plus 2026 is 0 mod 2000, whatever, let's call this n, mod n. Okay. So I hope it's visible. Okay, so now what is 2025 power 2026? You just have to raise to the power 1013. And whether that's useful. 2025 power 1013 minus 2026 power 1013. Is there some easier way to do this? Oh, this is, I see. This is like 2025 is x, then this is x square plus x plus 1. This is 2025 is x, then x square plus x plus 1 you have. And this is like x power 2026, well, which is x plus 1 minus x. So take x into x power x minus 1 kind of a thing, or x power 2025. So can I do it directly? Something like that. I don't know whether this is useful actually. 2025 into 2025 power 2025 minus 1. What happens when x square plus x plus 1 is 0? Then x cube, if x square plus x plus 1 is 0, then x cube is equal to 1. Right, because x cube minus 1 is a factor of x square plus x plus 1. So is that useful? X power 3 is 1, right? And this is what? This is x power 2025. I see. That I should not think of it as x power x. It's 2025 only. 5 plus 2, 7 plus 2, 9. It's a multiple of 3. 2025 is a multiple of 3, no? Yeah. So it's 1. So it's 0. Answer is 0. Nice. correct? 2025 over 2026 minus 2025. Yeah, I think it's clear to everyone, right? X square plus x plus 1 is 0 mod x square plus x plus 1. And this would mean if you multiply by x minus 1 on both sides, x cube is 1 mod x square plus x plus 1. And once x cube is 1 mod, then x power, once x cube is, I mean, essentially x is 2025, okay, that 2025 is not really playing any role. They call it x. Then what will happen is that you will see that this is just x square plus x plus 1, 2025 square plus 2025 plus 1. And you know that if you go modulo this number, x square plus x plus 1, then x cube is equal to 1 modulo x square plus x plus 1. That's simply because x cube, I mean, you can just multiply by x minus 1 on both sides to this equation. And once you get that, you notice that x is 2025, remember. So this can be written as 2025 into x power 2025 minus 1. But since x cube is congruent to 1 mod this fellow, this also is basically 0 modulo x square plus x plus 1. That's because x cube minus 1, x cube is 1 mod, right? So this also is 0, because notice you can raise this to the power something, whatever is the quotient. If you multiply by 3, 6 I 18, what is 2025 by 3? 6 I 18, 3 7s are 21, 675. 3 into 675, right? So the proof is the following. If you guys were not following, take this equation, raise both sides to the power 675. Then you will get 2025 is congruent to 1 mod x square plus x plus 1. Awesome, right? You see that x power 2025 minus 1 is divisible by x square plus x plus 1. Now you put x back as 2025. You will see that 2025 square plus 2026 divides 2025 per 2025 minus 1. And that's what, this is a factor of this, right? So 2025 into 2025 per 2025 minus 1. This is divisible by this fellow. So the product is divisible, so remainder is 0. Hopefully that's clear. The key trick is, this trick is often repeated, and it's like a trick that people miss, that if x square plus x plus 1 divides x cube minus 1, right? So because of which, that once you get x cube is 1, you can raise it to the power whatever you want. That's like the main trick. Right. Great. So for a real number x, the floor of x, or the greatest integer function, for example, the floor is 3.4 is 3, not 2, right? Let n be floor of root 27 plus root 23 power 6. Find the remainder when n is divided by 1000. How do you do this? Root 27 plus root 23 power 6. Well, they add up to 50, whatever is inside. I guess you can do by binomial theorem, but it's power 6, right? It's not all that bad. So root 27 cube plus root 27 into root 6 choose 1 into root 27 power 5, 27 power 5 by 2 into 23 power half, 6 choose 2, 15 into, now it's square, power 4, so 27 square into 23. Maybe going modulo 1000 is easier, I don't know. Similarly, I think it's symmetric, right? 6 choose 2, then there will be a 6 choose 3 term. Okay, 6 choose 3. But after that, 6 choose 4 will be similar, 23 into 27. Maybe that's the point. Make it life easier by symmetry, right? And here 27 power half into 23 power 5 by 2. Hope it's visible. 6 plus 6 choose 3, which is 20 into 27 power 3 by 2 into 23 power 3 by 2. So if you take root 23 into root 27 out, two plus half, then you will get 27 plus 23, which is 50. Not helping, I think. Modulo 1000 we are going, right? Because there's also a last term which I forgot. 23 cube. There's a lot of 50 that comes out. But is there some cooler way to do this? I want to know the last 3 digits. You all got different answers? People were estimating. So estimating is tricky though, right? I mean, I don't know what you mean by estimate. You can easily lose out. Estimation, accuracy can screw up the last digit. Although, maybe the trick is that usual trick, Maybe root 27 minus root 23. Is it less than 1? Maybe not. It is, no? Is root 27 minus root 23 less than 1? This is like 5 point something. This is 4 point. I think it's less than 1. Then we are done, right? This is that standard trick. Oh, this is a standard trick. This is JE, standard JE problem, right? You want to estimate, very standard trick, okay? I'll show you. So root 27 plus root 23 power 6 floor, okay? You want to calculate. But what you do is you ignore the floor and you add root 27 minus root 23. Superb trick, okay? It's power 6. You add this, it is less than 1. Now, the thing is that when you do this by binomial theorem, all the, because of this negative thingy, all the odd ones will all cancel out. Root 27 power 6 and root 27 power 6 will remain. So this will equal 2 times 27 power 3. Only the nice powers will remain. All the squares, all the integer parts will remain. And the 6 choose 1 term will cancel by positive negative. So it will be 2 times 6 choose 2 term. 6 choose 2 into 27 square into 23. Then 2 into 6 choose 4. 6 choose 3 will cancel. 27 into 23 square. So everything is an integer now neatly. 2 into 23 cube. Okay. Oh, it went out of screen. Sorry. So, sorry. It's here. So now the point here is that if you look at this sum, this is always less than 1, right? This is less than 1, as you guys have agreed. This is some number plus the sum part less than 1, okay? And their sum is an integer. So this plus, so which means you obviously know that the nearest, we know what's the nearest integer. We have a number, a real number x, and a number less than 1, y, which will add to an integer. This number is less than 1. So this is the fractional part of n. Y is the fractional part of n, x is the integer part of n. So this is the integer part. So n minus 1 is the integer part, essentially. So if you take whatever this number is, this minus 1 is the integer part. Because this is a fraction less than 1. And when you raise it to the power 6, it's still less than 1. Right? Positive number. So that's a trick. So that's it. So this is how you figure out the greater integer part of these some certain problems. It doesn't work always. It's a very specific trick. Will work when the difference between these two is less than 1. But yeah, now you have to estimate what is this modulo 1000, I guess, and subtract 1. And like, I hope people got it. Like, it's really nice, right? I mean, this is a trick I also learned when like teaching for JEE. It's not like so obvious. So whatever this number is, like, can we go mod 1000 and see what it is? It's like some. Is it nice? No, it's still. I think though, because the 2's appear now, 27 into 23 over there, 6 choose. 6 choose 2, 6 choose 4. Very sweet. I think we can do something nice. 227 cube plus 23 cube is a cube plus b cube. So it's a plus b into a minus b. So there's a 2 into. So 2 into 50 into 27 square. I mean, I'm not saying that we'll be able to do simplify everything. We have to calculate somewhere, I guess. 27 into 23. This is, I'm adding this piece and this piece. And here 6 choose 2, 6 choose 4. And 27 into 23 can be taken common out. So you will get plus 2 into 50 into 27 into 23 and into 6 choose 2. So 2 into 50, 100 is gone. So essentially 100 pieces come out. So we have to just go mod 10 on the remaining. So it's like, the screen will not be visible. So you go mod 10 on 27 square, which is like 9 plus, it just goes 9 minus 9 into I think that's correct, no? I want to know what is 1000. Hope I am talking sense. 6 choose 6 find 15 into 9, 5 into 9, 45. Am I making sense? So I have 100 into some quantity. Am I making sense? Sorry. I want to see what is it mod 1000. When divided by 1000, what remainder does it leave? 100n. What remainder does it leave when divided by 1000? I'm just saying, let's see what n is. 10n. Yeah, it's correct. Go modulo 10, that's all. Right. So that should like sort of tell us what it is. So 9 plus 45 is 54, I think. Hope that's correct. This is 100. Anyway, we can calculate this entire thing if you want. 7 into 3 is 21. Or 7 into 3, sorry. 7 into 3 is 21. This is 1. 6 choose 2 is 6 into 5, 30 by 2, 15. It's 15. It's not 45. It's 15. So 5. So 9 plus 5 is 14. So it's 4. So answer is 400 minus 1, 399. According to me. I think it's 399. Wait, how are you guys getting 199? I'm getting, if I go mod 10, if I remove the 100 part, 2 into 50 part here, I'm getting mod 10, this plus this is 1. This plus this is 4, modulo 10. So 100 into some number of the form 10k plus 4. So when you multiply, it will be 1000k plus 400. So the remainder is 400 when you divide by, and then you have to subtract 1. How are you guys getting 199? I think 399 is correct. 9. Did I miss here? 7 3 is a 1. Maybe that is the reason. This ends with 1. Maybe that's the mistake. So just calculate. Maybe I made a mistake here. 15. Yeah, maybe. 9 plus 8 is 17. 9 plus 9, yeah, this is 7 into 3 I missed. 7 into 21, 1. 17 plus 15. 7 plus 5, 2. Now I'm getting a different answer. I'm getting 199. Yeah, 199, correct. Okay. Alright, so answer is 199, not 399. But yeah, you guys learned an important trick. That's, I guess, the main point here. This trick is really cool, right? Like the fraction part. Always remember, there's like so many JEE questions on this. Not so many, at least few. Lots of competitive exams, so every once in a while ask this. this trick. Trying to compute the gradient function of something power with roots in between and all. Okay, problem 10. So we're going to maybe solve this and end the stream. Let's see. ABC is a triangle, D is on AC, and we'll continue next, maybe in a couple of days. So ABC is a triangle, D is on AC such that AB equal to BD equal to CD. AB equal to BD equal to CD. All angles of the diagram are positive whole number degrees. The largest possible size in degrees of angle ABC is AB equal to BD equal to, what is AB equal to BD is equal to CD. Okay, this is weird. All the angles in the diagram are positive whole number degrees. What is the largest possible value of angle ABC? In a couple of days IUQM, yes. Thursday, Friday. Wait, no. Friday is not IUQM. Sunday, right? So AD equal to BD. Okay, I think already angles have been marked. This is theta, this is theta. So this is, oh I see. So you have marked it as theta by 2, theta by 2. It's correct. By exterior some property. This is 180 minus theta, that's correct. So this angle is 180 minus 2 theta. This angle is 180 minus 2 theta. This angle is theta by 2. What is the largest possible value of angle ABC? AD equal to BD. I think, should we take the drawing into consideration? Yeah, all angles are shown. Like, 180 minus 3 theta by 2. What is the largest possible size of this angle? That will reduce on the largest possible value. How small can theta get? How small can theta get basically? Theta. Oh, because they said positive whole number degrees. So theta by 2 has to be, I see, all the angles in the diagram are a positive whole number, that's all. So theta is as small, theta can be as small as 2. So then 177, I think so, it's correct. Seems to be correct. So then theta is like 2, 2. Is there something going wrong? We should try to draw it and check once. So I mean, okay, this is very flat. It should be actually. This is a very bad drawing. Okay, let's reason on bad drawings. 2, 2. 180 minus 2 is 178. And this is like 1, 1. No problem. That's fine. And then this is 2, 2. This is like 176. It's okay, right? Yeah. Anyway, I mean, in the options, the largest possible is 177, and that works, right? We have an explicit construction. That's it, right? Yeah, thanks, Terpaisa. Why can't theta be 1? If theta were 1, then theta by 2 would be fraction. Yeah, that's fine. Okay. Great. Okay, so let's stop today. Maybe I'll do it tomorrow. I think we should solve a few before IOQM. Although I don't know whether there are IOQM level problems, at least we'll revise for IOQM as we go along. It's okay, tomorrow let's stream it then. So thank you guys for joining. So good night. See you all tomorrow. Bye.